Find the linear function with the following properties. F of 2 equals 10 and the slope of f equals -3. Recall that a linear function is just a function that has this form. F of x equals mx plus b. And that is exactly the same as the slope-intercept form for the equation of a line. So what that means is, when they ask you to find a linear function, it's just basically exactly the same thing as asking you to find the equation of a line. Okay, so it is an equivalent problem. It's just that the wording is slightly different. So this problem then that says find the linear function with these two properties is exactly the same thing as find the linear equation of a line that has certain properties that we're going to translate now. The statement f of 2 equals 10 is really equivalent to saying that the corresponding line passes through the point x1, y1, where x1 is 2, which is the input, and the y, which is the output, is 10. So the line passes through the point 2, 10. Okay, these two things are equivalent. And the slope of f equals -3, that's equivalent to saying that the line has slope equal to -3. So we have these two pieces of information, and now we just have to find the equation of the line that has this m and passes through this point. And for this, we're going to use the formula y minus y1 equals m x minus x1. Remember that this is a formula you're supposed to memorize, and it is used a lot in calculus, so you're required to memorize it. Okay, so now it's just a matter of plugging in these numbers in there. So we would have y minus y1 equals 10, m equals -3, and x1 equals 2. Right, and now let's solve for y, simplify this. So this is y minus 10 equals -3x. Multiplying here, you get +6. And then lastly, add 10 on both sides, move this 10. It will be 6 plus 10, so that would be 16. Okay, so that is the equation of the line that passes through this point and has this slope. They're not asking for the equation of the line, they're asking for the linear function. So that means we have to give the answer using functional notation. So that means instead of writing y, we're just going to write f of x. So we're going to say the linear function is f of x equals -3x plus 16. Okay, this is using functional notation. Find the linear function with the following properties. F of -2 equals 8 and f of -1 equals 6. Finding the linear function that satisfies these two properties is equivalent to finding the equation of the line that passes through the 2 points encoded in this piece of information. So, what are those 2 points? Well, the input being -2 means that that's the x-coordinate, and the output being 8 means that that's the y-coordinate. So this information right here is equivalent to saying that this point is on the line. What point? -2, 8. This piece of information, f of -1 equals 6, is equivalent to saying that this other point, second point, -1, 6, is also on the line. So now I'm looking for the equation of a line that passes through these 2 points. So how do you do that? Well, we're going to use the formula y minus y1 equals mx minus x1. Enter the formula m equals y2 minus y1 over x minus x1. We have 2 points. The first thing we need to do is find the m. So let's find the slope. Let's plug in our numbers. So we get m equals y2 minus y1, so 6 minus 8, over x2 minus x1, so negative 1 minus negative 2. Careful with all those signs. 6 minus 8 is negative 2. 2 minuses here gives me a plus, so negative 1 plus 2. And then we would get on bottom negative 1 plus 2 is positive 1. And negative 2 divided by 1 is just negative 2. So now we have the m. Now using the m and x1, y1, this one right here, we would plug it in here and get our equation. So now we would get y minus y1. y1 is 8 equals m, which is negative 2. X minus x1 is negative 2. Now let's solve for y. Simplify here first. 2 negatives gives me a positive. Now distribute. So this will be negative 2x. Negative 2 times 2 is negative 4. And now add 8 on both sides, or move the minus 8 to the other side. It becomes plus 8. Negative 4 plus 8. Negative 4 plus 8 is positive 4. Okay, so that's the equation of the line. Now, they're not asking for the equation of the line. They're asking for the linear function. So we just have to just give the answer using functional notation. Instead of writing y, we write f of x. So f of x equals negative 2x plus 4. This is the linear function. A little review about parabolas or quadratic functions. Suppose you have this quadratic function, f of x equals x squared minus 6x plus 5. Find the vertex. Okay, for finding the vertex, you need to remember the formula for the vertex. The vertex is hk, where h is negative b over 2a. Okay, negative b over 2a. You have to memorize that if you haven't. If you have memorized already the quadratic formula, which you're supposed to, then it is easy to remember this because, right, this is a quadratic formula. So this formula right here is just this piece of the quadratic formula. Just get rid of the square root part. Negative b over 2a. Okay, so if you remember the quadratic formula, you can remember this. So that would be the h, which is the x coordinate of the vertex, and then the y coordinate of the vertex. Well, y coordinate, y is f of x. So that means you just plug in the x being this. So in other words, plug in h. So you can just say h, okay? Just plug in h. You can just say x equals f of h. Okay, so those are the formulas that you're supposed to memorize. And now we're just going to plug in the numbers. This is the easy part. So h is going to be negative b over 2a. Negative b is negative 6. So negative 6 over 2. The a is 1. So this is just 6 over 2, which is 3. And now the k is what you get when you plug that in the formula. So f of 3. Plug in 3 there. What do you get? You will get 9. 3 squared is 9. 6 times 3 is 18. So 9 minus 18 is negative 9. And negative 9 plus 5 is negative 4. So k is negative 4, which means that the vertex is 3, comma, negative 4. Now let's find the x-intercepts. The x-intercepts is when you set the y equal to 0. The y is the f of x, so setting y equal to 0 is the same as setting f of x equal to 0. So we're going to get then 0 equals x squared minus 6x plus 5. So we're going to get 0 equals x squared minus 6x plus 5. And this is a quadratic equation. You can solve this any way you want to. You can use the quadratic formula, or you can factor if it's easy to factor. This one actually factors easily. X minus 5, x minus 1. So if you're factoring, then set each of the factor equal to 0. And this gives me 5 and 1. So that means the intercepts, remember the intercepts are actual points on the graph or points on the plane. The intercepts would be 5, 0 and 1, 0 because they're points on the plane. Okay, and lastly, graph the parabola. For graphing the parabola, that is just easy. All you have to do is plot the vertex, plot these 2 points, and connect to them in the shape that you know parabolas are supposed to have. So let's do that. I'm drawing the axis. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5. 6. 1, 2, 3, 4, 5, 6. Okay. So here are my axes. We have to plot the vertex and the intercepts. The vertex is 3, negative 4. So 3, negative 4 would be here. That's the vertex. Okay, this is the vertex. Then the intercepts, the x-intercepts would be 5, 0. So 5, 1, 2, 3, 4, 5. Right here. And 1, 0, which is this one. If that's the vertex, so just connect these. It doesn't have to be perfect. And there you go. That's a parabola. Intervals of increase and decrease. Okay, intervals of increase are those intervals where when you move from left to right, the graph goes up. And intervals of decrease would be those intervals over which the graph goes down as you move from left to right. Always you move from left to right, just like the way you would read words, from left to right. And then constant is just when it's perfectly horizontally flat. If there's any region of the graph where it is perfectly horizontally flat, then those are intervals where the function is constant. Okay, so in this question says, look at this graph and say, or indicate, what are the open intervals where the graph is increasing, decreasing, or constant? Okay, so as we move from left to right, the graph goes down up to here. We are moving from left to right on the graph. So if we're moving from left to right, we're going actually down and then we go up. So we're tracing this graph from left to right. So if we're tracing this graph from left to right, we actually have to go down with a pencil and then up. Okay, so ignore those arrows. It's just the way you would trace this with your pencil if you go from left to right. If you're drawing this curve from left to right. So the curve would go down up to here, up to this point. So all the way from minus infinity from left, because the graph keeps going forever to the left, from minus infinity to this point. Now, what is the x-coordinate of this point? Well, you go from minus infinity up to 1. It's the x-coordinate that matters here, not the y-coordinate. So it is decreasing from negative infinity to 1, and from that point onward, you go up, so that means you're increasing. So it is increasing from 1 to infinity, because the graph keeps going to the right and up forever. And then intervals where the graph is constant, well, this particular graph doesn't have any intervals where the graph is horizontal, so it does not apply. Evaluating compositions of functions. So suppose they give you two functions, f of x equals something, square root of 2x plus 10 in this case, and g of x equals some other thing, in this case, x squared minus 13. Question is, can you evaluate this composition? F of g of 4. Find f of g of 4. And one other way of writing that could be f circle g of 4. So in other words, f composed with g evaluated at 4. These two things are the same. Okay, so you start by evaluating this from the inside out. So that means you're supposed to find you're supposed to find g of 4 first. Okay, you evaluate from the inside out. So find g of 4 first. So plug in 4 here. G of 4 would be 4 squared minus 13, which is 16 minus 13, which is 3. And then you take that and you plug it in f, because we already did the g. Now, since we're going from the inside out, right? We already did the g, now we do the f. So now what we got, we plug it in the f, and that's it. Let's plug in 3 in the f. So here's the formula for f, so plug in 3 there. Square root of 2 times 3 plus 10. This is what? Square root of 6 plus 10, which is square root of 16, which is 4. And that's it. It's over. The answer is 4. F of g evaluated 4 is 4. Find the formula for the inverse function f of x equals x plus 1, all that over x plus 2. Okay, let's review what are the steps for finding the inverse function of a function. Step 1 is you're going to replace f of x with y. Okay, so that means instead of writing f of x, you're going to write y. So this is going to look like this. Y equals x plus 1, all that over x plus 2. So step 1 is just a change of notation. Step 2 is going to be, you're going to swap the y and the x and the y. So wherever you see y, you're going to write x. Wherever you see x, you're going to write y. So this is going to look like this. X equals y plus 1, all that over y plus 2. Because an inverse function, that's what it does. It replaces inputs with outputs. Swaps them around. Okay, step 3 would be you're going to solve for y. So the equation that you just got in step 2, you're going to solve for y. Okay, so let's do that. This is a rational equation, so we're going to multiply both sides by the LCD of all the denominators that we see. There's only one denominator, so that denominator is just going to be the LCD, so that means we multiply both sides by that denominator. So the left-hand side is going to look like x times y plus 2, and the right-hand side, okay, we're multiplying by that denominator. That's going to cancel here. And we end up with x, y plus 2, in parentheses, equals y plus 1. Now we want all the y's on the same side, because we're trying to solve for y. So we want all the y's on the same side, and before we can put them on the same side, we need to get this y that is inside this parenthesis, we need to get it out of there, so that means we need to distribute it here to get it out of there. So this is going to be xy plus 2x equals y plus 1. Now we can move all the y's to the same side, either all the y's to the right or all the y's to the left. I'm going to move them all of them to the left, so that means I'm going to move this y to the left, and I'm going to get xy minus y. And then I'm going to move this 2x to the left, to the right. We're going to get negative 2x plus 1, this one right here. Okay, what do you do now? You factor the left-hand side. The y is repeated is a common factor, so factor it out. You get x minus 1, negative 2x plus 1. And now you divide by that. So you get negative 2x plus 1, all that over x minus 1. And the problem is pretty much over. The only thing that remains is to report the answer using functional notation. Okay, so in other words, replace y with f inverse of x. So that means report the answer using functional notation. That would be f inverse of x equals this thing. Negative 2x plus 1, all that over x minus 1. And that's our final answer.